Here we are back at it with review homework number 2. Let's do it. Number 1 says to find the inverse of g of x. So in order to find the inverse, the first step is instead of writing g of x, we're going to write y. And then we're going to switch the spots of x and y. And the reason why we're doing that is because we are pretty much doing everything in the reverse order in order to find the inverse. So when looking here, you want to get y by itself. So I asked myself, what is a nice move that I can do? I see that I'm adding 4, so to undo that, I'm just going to subtract 4. And that leaves me with x minus 4 equals 3 times y minus 1 cubed. So if I look at this, I see two things. I see multiplying by 3, and I see that we're cubing it. So the question is, what do we do next? So a lot of us might be tempted to take the cube root next, but the problem with taking the cube root is the fact that that 3 in front is still there. And you don't want to take the cube root because that 3 in the front is going to be trapped. So what I would actually do is I would divide by 3, because when you divide by 3, we now get x minus 4 over 3 equals y minus 1 cubed. It's during this step that you can actually take the cube root in order to get rid of the power of 3. So you see now cleanly the power of 3 is gone because cube rooting it gets rid of that. So you're left with y minus 1 equals the cube root of x minus 4 over 3. And then to get y alone, we're going to add 1 to both sides. Also, I want you to notice that the plus 1 is not inside the cube root, it's on the outside. And do you see how we've isolated y by itself? And remember that our original function was g of x. So I'm going to show you the fancy notation, which is g inverse of x equals pretty much what we have above. And this is how you do the inverse, and this is your final answer. So I think if you remember to switch x and y and you remember the algebra, you'll probably be fine with this one. Just takes a couple of times to do it to remember it. The next question is writing an expression that's equivalent. So remember when it says write an expression that's equivalent, you're not solving for anything, you are just rewriting it. So the first thing I want you to notice actually is I made a typo here. It's not x squared minus 11x plus 20. It should be x squared minus 9x plus 20 over x squared minus 4. So when making this, I just made a little math mistake. So instead of negative 11, everybody, it should be negative 9. So what two numbers multiply to 20 add to negative 9? That's going to be negative 5 and negative 4. Just to show that, negative 5 times negative 4 is positive 20. Negative 5 minus 9 is negative 9. On the bottom, we have x squared minus 4, so that's going to be x minus 2 and x plus 2. So normally, a lot of times, something will cross out, and that would be the next step. But here, nothing actually crosses out, and so there's nothing wrong with that. We're actually done with this question, and this would be my final answer. So most of the time when you do this type of problem, something will actually cross out, but here, that's not the case. All right. Number 3 says, what is the equation of a circle with a diameter of 4 and a center located at negative 3 comma 4? So the first thing I'm going to do is I'm going to write the equation of a circle. So h comma k, remember, is your center, and r is your radius. So my center is negative 3 comma 4. So when I do x, it's actually going to be plus 3. And that's to show that, if I wanted to, it's x minus minus 3, and it's y minus 4. And then if the diameter is 4, that means the radius is 2. So it's going to be 2 squared. So your final answer is going to be x plus 3 squared plus y minus 4 squared equals 4. And then you're done. So once again, you had to remember the formula. Second of all, the center is going to have the opposite signs of whatever is given. And then if it gives you diameter, make sure to find the radius first and then take that value and square it. Number 4 gave people trouble. So let's talk about this. So Charles is making a decorative tablecloth for his small circular table. So I draw a small circle. The table has a radius of 50. So do you see while I'm reading it, I'm starting to label it? And a height of 40. This might be a little weird to draw, but I'm just going to actually just draw a leg like this and write 40. She wants a tablecloth to hang an even 10 centimeters above the ground. Which design will give Charles what he wants? So if we think about a tablecloth, when we put it on top of the circle, it's going to hang down. So to me, it's important to actually extend this picture, because if I go like this is also 50, and then we have another leg, which is 40. So we want to cover this whole table. So if we think about it, if we cover the whole table, then we're going to cover all of this for sure. And then we want the tablecloth to hang, right? So if we want it to hang, and we want it to be 10 centimeters above the ground, I'm going to put these black marks to indicate that we don't want the tablecloth to go all the way down to 40. We actually just want it to hang 30. So the whole leg is 40, but we want the tablecloth only to extend 30 because we want it to hang 10 centimeters above the ground. So if we look at the picture that we have, do we see that the tablecloth is covering 50 plus 50 plus 30 plus 30. So the diameter of the whole tablecloth, if we think about it as being one long strand, is actually 160 centimeters. And this is equivalent to the diameter. So once again, I want you to think of the tablecloth as some big tablecloth that is 160 centimeters. And you're just putting it on top of a circular table. And since the question asks for the radius, we just divide this by 2, and then we get 80. So I think the hardest part of this problem is actually like drawing this picture and just understanding what it's saying. So I hope that makes sense. If you have any questions, just leave any comments, or just please make sure to bring it up during class. But I hope this picture and visual kind of helps you with this problem. All right, let's move on to number 5. So number 5, please read number 5 carefully. So the function f of x is given by this equation, which of course says g of x instead of f of x, right? So let's make this f of x. So if f of x is given right here, the values for the quadratic function h of x are shown below. So we're given the equation of one function, f of x, and then we're given the table of another one, h of x. So the y-intercept of f of x is blank units above the y-intercept of h of x. So it seems like in this problem that they're comparing the y-intercepts for both functions. So what we should do is, let's find out what's the y-intercept of f of x. So remember that y-intercept is 0, comma y. You're substituting 0 for your x value in order to find your y. So what you should do for f of x is actually to substitute 0 into the equation to figure out what the y-intercept is. And then negative 3 squared is 9. And then 18 minus 3 is 15. So the y-intercept for f of x is 15. But then for g of x, everybody, do we see that this right here is our y-intercept? So our y-intercept for h of x is negative 6. So the y-intercept of f of x, which is 15, is how much above negative 6? So 15 and negative 6. So if we think about a number line, 15 is here and negative 6 is here. So do we see that 15 should be 21 units above the y-intercept of h of x? Because 15 and negative 6 are 21 units apart. I mean, another way to draw this, actually, let me just draw it a different way, which probably make more sense to all of you, is if this is 0, 15, and this is 0, negative 6, the distance between here is 21, because from the origin to 15 is 15, and then from here to here is 6. 15 plus 6 equals 21. So that's why the answer is 21. So once again, excuse the g of x, it should have been an f of x. All right, now let's do the last problem. So the last problem, you're given a systems of equations. So you're given two functions. So you're given f of x and g of x. What is the greatest value of x for which f of x equals g of x? So one thing I need you guys to know is this just means intersect. Okay? So what is the greatest x value for which both functions intersect? So if they're saying greatest, I'm guessing they intersect in more than one spot. So since I don't have the TI Inspire on my iPad, I'm just going to go to Desmos and show you that these are the two graphs. And they touch right here and right here. So the two values that they intersect is at negative 7.472 and 1.472. So the question asks you to give the greater x value, where they intersect. So the greater number here is just 1.472, and that would be your final answer, and that's it. So x equals 1.472, and just remember, the hardest part about this question is A, making sure that you read what is the greatest value, and B, understanding when it says f of x equals g of x, that is asking you where the two functions intersect. Hope this video was helpful. Once again, I apologize for, question 5. It should be f of x instead of g of x. And then for question 2, I wrote negative 11x instead of negative 9x. Two little errors, but hopefully they make sense. All right, have a good day.